Hello, it's Mr. Neil here. In this video, we're going to work through the database task from the 2023 Higher Computing Science assignment. The database task within the Higher Computing Science assignment is always worth 15 marks. In 2023, there were two different parts. Part A was worth 2 marks and required you to demonstrate some analysis skills. Part B was worth 12 marks, majority of which focused on SQL queries. However, there was also some evaluation. Let's dive in and look at Gnome Sweet Gnome, a company that sells garden gnomes. The owners want to create a relational database to store details of their customers, orders, and garden gnomes. They have appointed a database developer to do this. Task 2A. The developer asked employees about the features that they would like in the completed database. On the right hand side of the screen, we have a summary of the feedback from the users of the database. These are our end user requirements. It has been identified that a database needs to be created with 4 entities: customer, customer order, gnome purchase, and gnome. Using the information gathered from the employees' comments, we need to identify 2 additional requirements of this database. When identifying functional requirements, it is useful to use this sentence structure. We're starting with that most of our functional requirements will be a query to do something. This could be to select something, to insert, to update, to delete, to calculate the maximum, minimum, average, number of, total, and then a specific context to the problem. So for example, if we look at the first end user requirement, I would like to view the details of the gnomes in order of popularity. Then a functional requirement that could sit aside that would be a query to display the details of all gnomes with the most popular listed first. Why don't you have a go at coming up with some more functional requirements, and we'll have a look in a second at these. So let's have a look at what the SQA said was acceptable answers to this task. You'll see here that they have identified 6 functional requirements, and each of these relate to one of the end user requirements that we were provided with. I touched upon that we wanted a query to sort the gnomes by popularity. We want a query to search for order details, including date and total cost, and that can be associated with this end user requirement here. A query for search for customers who placed an order in a given month, that can be associated with this end user requirement here. A query to search for customers regarding special offers can be associated with this end user requirement here. The rest of the end user requirements relate to the update, insertion, or deletion of information. And lastly, the last one is that we need to calculate the total cost of an order. You require any 2 end user requirements to gain 2 marks within this part of the assignment. Once you've completed this part of the assignment, you then move on to part 2B. Before we get to part 2B, let's have a look at the structure of our database. We have got 4 entities. We can clearly see from the entity relationship diagram the primary keys denoted by underlined and the foreign keys denoted by the asterisk. At this stage, it may also be useful to look at the database file. For the context of this demonstration, I'm going to be using Microsoft Access. We have got our 4 tables, and we can inspect the information within them. We've got customers and their address along with their email addresses. We can see the orders that they've placed and on the date that they've placed them. We can see what gnomes consist of each order and the quantity of gnomes in the order. And then lastly, we can see all the information about the gnomes. Within 2b, we would like to produce a list showing the number of gnomes sold with the word solar in the description. And we're looking for this result here. So before we go into SQL, let's break down what we're looking for. So the first thing is we need the gnome name. Secondly, we need the total gnomes sold. So we're looking for an attribute that will allow us to give us the number sold. So that's probably going to be quantity. And because we're pulling information here from two tables, gnome and gnome purchase, which means we will need an equijoin to join the primary key for gnome with the foreign key for gnome purchase. So let's combine this into an SQL query that will display the gnome name and the quantity purchased for every gnome. So we're going to select the gnome name and the quantity from the gnome table and the gnome purchase table. And we'll need our equijoin where gnome.gnomeid is equal to gnome purchase dot gnomeid. Let's run this query and we'll see that we've got every gnome and every time that it was ordered. Let's now look at the second part of this query. We want to show the total number of each sold. So let's now think about how we work out a total when we have the different values that we want to. We want to total up quantity for Maximilian, total up quantity for Aiko. So this is where we're going to use our sum aggregate function. So we're going to sum quantity. Now because our select line contains an aggregate function and a field, and this field is the field that we want the totals for, we're going to add our group by in. And we'll run that. And we can see what we now have is the name of each gnome along with the number sold for each gnome. Now Microsoft Access has called this field EXPR1001, but we want to call it total gnomes sold. So to do that, we're going to add in our alias as total gnomes sold. Let's run our query and we get total gnomes sold. Like so. So now we need to narrow it down so that we only see those that with the word solar in the description. To do this, we're going to have to use the field description. If we return to our database and have a look at the description, we can see that solar can appear anywhere within the description. So we're going to have to use an alias to achieve this. So we're going to add a second condition in, and we're going to say where description is like, and we're going to use our wildcards to say that we want any character before solar and after solar. Now when we run this, we will only get those gnomes that are solar powered. Are we finished yet? We need to implement an SQL statement to produce the following output. So whilst we have Coleman, Maximilian and Danny, they're not in the right order. If we look at the total gnomes sold within the expected output, these are in descending order. So we need to add in our SQL code for that as well. By the sum of quantity descending. So when we run that, we now get Coleman, Maximilian, Danny. What I would now do is I'd go to my SQL view, screenshot this code and paste it into a document to submit to the SQA with my evidence. Let's take a look at the marking scheme and see where we get the marks for this question. So let's bring in my solution. Here is my solution, and let's look at the marking scheme. So we get 1 mark and 1 mark only for summing the quantity. We get 1 mark for bringing the 2 tables and the equijoin. We get 1 mark for our alias. We get 1 mark for a wildcard. We get 1 mark for our alias and our group by. And then the 5th mark is for the order by. Moving now on to part 2C. A discount voucher will be sent to customers who bought 3 or more of the most expensive gnomes available in a single order. Implement the SQL statement to produce the output shown below. So this output shown below pulls the email address, the order ID, which we can come from the customer order, or the order or gnome purchase, let's pull it from there, and the quantity. So because this query, as we view it, is pulling from 3 tables, we're going to need our equijoin. Now the SQA have worded this interestingly. They have said implement the SQL statements. Okay, the fact that they have included that pluralization of statements indicates that they want us to do 2 queries. Okay. The first query that we need to ascertain is we need to ascertain the price of the most expensive gnome. So let's head to Access and implement our query to do that. In order to find the price of the most expensive gnome, I'm going to select the max unit price from the gnome table. I'll execute this and I'll see the most expensive gnome is £17. Again, we're going to go back into SQL view and we're going to give this an alias. Expensive. Okay, and I'm going to make a wee note of what I've called this alias, as we will need it at a later date. I'm also now going to make sure I save this query, and I'm going to give it a name, most expensive. Again, I'm going to write that down as I will need it later on. Okay, go. So we now have identified a query that gives us the price of the most expensive gnome. Let's move on to the other part of this query. we need to identify the email address, order ID, and quantity for all orders. Here I have the SQL that will identify the email address, the order ID, and the quantity of each gnome ordered by a customer. Because we're pulling email address, customer order, and quantity from the three tables, we need our equijoin. And there we can see that Clara ordered quite a lot of gnomes in her orders, and so on and so forth. Let's now get orders that only included 3 or more gnomes. So in this case, I'm going to say and quantity greater than equal to 3. So we can now see that these here all have 3 or more orders, 3 or more gnomes in the order. The last bit is the tricky portion. We know the cost of the most expensive gnome has been stored in our query here. We're going to import this query into this query by adding it to our from line, from most expensive. We're then going to say that we want the price, the unit price, to equal most expensive. I'm now bringing in the gnome table. So again, I've got my relationship between the gnome and gnome purchase. So we're going to say the unit price is equal to most expensive, which is the field, which is equal to expensive, which is the field in the most expensive table. So now when I run this, we can see that we get the 2 results. So again, I'll take my SQL. This time, I need to screenshot both queries. So there's my first query. And we'll paste that into the SQL documentation ready to be sent away. And then we'll get the other query. And screenshot that. And we'll paste that in as well. So let's have a look at how the marks were awarded for this question. So we get 1 mark for using the max to find the most expensive gnome. We then get another mark for the whole first query. Now, if you're using pure SQL, for example, MySQL or SQLite, you may do this as a view and you still get the same mark. We then get another mark for our condition to check for greater than or equal to 3, and it matches the unit price. And then the last mark is for the rest of the SQL statement, making sure that we have select, from, where, and all our equijoins for 4 marks. Let's now move on to part 2b. Let's now move on to part 2d. A query is designed to add 20% VAT to all orders. The query is tested using ORD 0024. The expected output is shown below. The query to test the above SQL statement is provided with the database. When run, the actual output does not match the expected output. Amend the query to produce the expected output as shown above. So let's have a look at what the actual query says. Query for 2D. So when we execute this, we get Sandy Care multiple times. and we get each of his orders and the price including VAT. And we want to total this up to get all orders. So if we are totaling this all up to get all orders, then we're going to use sum. So we're going to sum this calculation. Now, like before, we now have two values in our select line that do not have an aggregate function. So in this case, we're now going to group by those two options. Now, when we execute the query, we get the result we're looking for. Now, you'll notice that in Access and other database engines may do this, we don't have the 0 because we don't write zeros in decimal numbers. That is okay. So again, we'll go get the SQL and we'll screenshot that and put it in for submission with the rest of my task. So then we go, do a space for it on this slide, but it can sit there. There we go. Okay, and if we look at the marking scheme, we have got one mark because we have added in the sum, and this is where you may wish to highlight where you've edited the query. By highlighting the query, it really points to the SQA marker where they're looking to give you the mark. So I'm highlighting the two portions that I've added in because, as you'll see from the marking scheme, we get one mark for each of them. So we've now completed task 2B, 2C and 2D. All of those are the SQL implementation portions of the 2023 assignment. The last portion is task 2E, and this is an evaluation in terms of fitness for purpose. And we need to try and make sure we turn this answer and link it back to the assignment itself and the context that we're looking at. A customer requests a copy of a previous order for an insurance claim. Evaluate the accuracy of the output when running a new query to produce a copy of the original order, by firstly explaining why the copy of the order may not reflect the price paid at the time, and then secondly describing how the database could be amended to rectify this. So if we think about how we've calculated the cost in this database table so far, we have used a unit price, we have used a quantity. Okay. We know from the analysis that there's options for discounts, and the previous task talked about discounts. So how could they all influence the price paid then when they bought it and the price paid now? And how could we negate that and add to our database to remedy that fault? Let's have a look at what the SQA we're looking at. So for part I, you could have put that the unit price has changed. If the unit price has changed, then the calculations will all have updated. VAT may have been included or it may not have been included. A discount could have been implied. That would ultimately affect the final cost. So part 2, how do we negate this? Well, what we do is we add a field that stores the order total so that we know how much the customer actually paid. So in this video, I've kind of given you a walkthrough of the database task from the 2023 Higher Computing Science assignment. Ahead of you starting your assignment, I would encourage you to practice different assignment tasks, and you'll find plenty of these on the SQA Past Paper website.